Yeah, you can ask Ankit Kumar. Are you able to see my screen?
Yes, sir.
In this session, we will discuss about the week 5. The complete week 5 with some examples. Like first, I will start with the contents, week 5 contents. First, I mean, like, if you see the first thing in the week 5, there are like some tests to know whether the relation is function or not. So what are the tests? We conduct 2 tests. First one is vertical test. Here, vertical test is like it confirms relation function. I'm coming to the horizontal test. It says that function is, if a graph satisfies the horizontal test, then we can say the function is 1, 1. We will discuss in brief, don't worry. This is just an outline. Okay? Hello?
Yes, sir.
I'm coming to the next part. That is types of functions. Increasing, decreasing, 1, 1. Then at last, the main topic of the week 5 is exponential functions. And then in this, we discuss about graphing the exponential function. What is natural exponent? And finally, we will do some example problems. And then the last topic of the week 5 is like composite functions. And applications of composite function, that is inverse of a function. Okay, clear till now? Hello?
Yes, sir.
Yes,
Clear.
sir.
Yeah. Now we will move on to the first topic. Like what is vertical test? test. So suppose there is a relation. If you plot that relation like something like this, now we have to draw a vertical line which is parallel to vertical line. Make note of it, parallel to which axis?
Y-axis.
Y-axis. Parallel to axis. Draw a line parallel to y-axis. Look, it is touching at 2 points. So this relation fails vertical test. What can we conclude if a relation fails the vertical test? It's not a function. Agree?
Yes, sir.
Yes,
Yes,
sir.
sir.
And then coming to the horizontal test. Horizontal test. For suppose there is a graph like this. Now what should we do? You have to draw horizontal line which is parallel to horizontal line parallel to x-axis like this. Look here, it touches us 4 points. So look, this function is not, if it fails horizontal test, what is that? It is not 1 1.
It's many one.
It is not 1 1. Okay, how can you say? My question is right here. How can you say that a function passes horizontal test? Can anyone answer this question?
At multiple
Yeah.
values of x, we are getting same value of y.
Yes, sir. If x1 is not equals to x2, then f of x1 also not equals to f of x2.
No,
Then
I
we can
want
say,
graphically. I want the answer graphically. So using graph.
if
Sir,
the
if
if the
f
if the
x1
horizontal line if the horizontal line cut only one time of fx.
Yeah. So suppose let us take something like this. Okay.
Yeah, sir. We can also say a graph is monotonic.
At most one time. Intersect horizontal line, intersect at most one time. Okay, remember this carefully. Okay, clear? Now
Yes, sir.
look, listen this very carefully. I am drawing three graphs. Hello.
Yes, sir.
Just wait. Okay. Now answer. What is the common thing? Like, what did you observe? All these graphs.
Sir, all the graph is 1, 1.
Yeah,
All the graphs are one one. You can clearly say all the graphs are one one. What is the common thing you observed here? Like, see what is
Sir,
this?
all graph passes horizontal test, sir, and also vertical test.
We can say one one because it passes horizontally. Observe these graphs carefully. What is this graph like? X-axis, sorry, x-axis, y-axis. Decreasing function. Agree? Hello.
Yes,
sir.
sir.
This is increasing function.
Yes, sir.
What is this?
So this is also decreasing function.
Decreasing function. This
And increasing.
increasing.
increasing function. If at all, listen this carefully. If at all any function is decreasing or increasing, you can say the function is one one. If at all function f is increasing or decreasing, then f is one one. Agree?
Yes, sir.
Yes, sir.
Clear till now? Why it
Yes,
is
sir.
one one?
Clear.
Can anyone tell why it is one one? Look, one one says
Sir,
that
because
Because
if
every value of x
uh,
is unique,
yes, different
yeah,
values of y.
f of x1 is
distinct.
equal to f of x2 if and if only x1 equal to x2. So increasing or decreasing, what happens if x increases, y increases? So, or decreases if it is decreasing. That is the reason why, as it follows this. as it follows this increasing and decreasing function follows this. So it is automatically 1, 1. Clear?
Yes, sir.
Clear, sir.
Now we'll move on to the next question, like next topic. Exponential function. What is exponential function? What is the form of exponential? F of x is equal to a power x. Here, remember this carefully. A must be greater than 0 and a not equal to 1. Why? Why these two?
Sir, because less than 0 exponential function is not defined, and at a equal to 1, every fx equal to 1.
Yeah, it becomes constant function. A equal to 1, it becomes constant function. Coming to the a greater than 0. Why a is always greater than 0? Because you will get to know. Look, hello,
Yes,
hello,
sir.
are you able to hear me? You will get to know when you learn about logarithms. In the next clip, I will try to brief, like very simply. For suppose, let's suppose minus 1 by 2 whole power x is equal to f of x can be written as y. What happens is that if you learn logarithms, you can use log y is equal to log minus 1 by 2 x whole over x. Look, what happens is that log of negative value is not defined. I think you all have mobile phones now. Hello?
Yes, sir.
Yes, sir.
Yeah.
Yes,
Go to calculator and press log of minus 3 any value minus. Don't worry, you will get this in week 6.
Yes.
Yeah. What is it giving? Log of negative value. Yeah. Are you getting the point? You will, don't worry.
In iota, we are getting
Yes, a complex number.
complex number.
Week you will get clarity in week 6. Don't worry. This is week 6 topic. That's it. Because I want to clear why this greater than 0. Clear? Clear, everyone?
Yes, sir.
Yes, sir, clear.
Calculator to check. Okay. Now coming to the rules. Rules of exponents. Exponents. Some says laws. Some says indices. Some says look for suppose a power s into a power t is equal to a power s plus t. Look, remember this. Both base must be same. Agree? Hello.
Agree,
If
sir.
yeah, if 3 power 6 into 4 power 6, sorry, 4 power 8, you can't do like 6 plus 8 whole power 3. This is wrong. Bases must be same. Then coming to the a power s divided by a power t is equal to a power s minus t. Next one, a power s whole power t is equal to a power s t. ab whole power s is equal to a power s p power s. Then 1 by a power minus n is equal to 1 by a power n. Clear?
Yes, sir.
Someone is asking some doubt, I think. Hello? Clear till now?
Yes,
Yes,
sir.
sir. Clear.
Yeah. Now I will ask you some question, like 1024 whole power 18 and 512 whole power whole power 36. Which is greater value? Which is the greater? Which is greater?
So 1024 power 18 is greater number, sir.
Let everyone answer that.
So 512 about 36.
How did you get that? Look, let us factorize this 1024. 2, 5, 1, 2. It can be written as 2 into 512 whole power 18. Agree?
Yes, sir.
Then coming to this one. 512 whole power 36. Now listen this carefully. We can only compare these two. We can't compare these two. Why? Powers are different and bases are also different. Agree?
Yes, sir.
Powers are different and bases also different. Anyone must be same. You can compare if 512 whole power 18 and 512 whole power 36. You can compare because bases are same. Greater the power, greater the number. Are you getting the point?
Yes, sir.
Hello? Now what we should do is that we have to equal the bases, like at least look 512. We will further do this 1024, 2, 512, 2, 2 to the 4, 5, 6, 200, 64, 32, 1, 3, 4, 5. Look, 2 power 1024 is equal to 2 power 10. It comes like 2 power 10. You can check. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Plus 2 power 10 whole power 80. And from this side, Look, 5 and 2 is very easy. Like 1, 2, we will do 5 and 2 as 1, 2. It comes like 2 power 9. Are you getting the point?
Yes, sir.
Yeah, you can check if you want. Like in this set, it comes like 2 power 9 into 36. Two power 324, 2 power 180. Which is greater value?
2 power 330, 24.
Yeah. This value is great. Clear?
Yes, sir.
Yeah.
Yes, sir.
Then coming to the next, next topic, natural exponent. It is like e power x. Listen this carefully. E is greater than 1. Okay, not this. I need to first clarify how graph looks like. Sorry. Okay, we defined what is exponential function. We have defined what is exponential function. It is in the form of f of x equal to a power x. They gave a greater than 0 and a not equal to 1. What are the possibilities then? A can lie between 0 and 1. Agree? Hello?
Yes, sir.
We'll see the possibilities. A can lie between 0 and 1, or A can be greater than 1. Clear till now?
Yes, sir.
Yes, sir.
What is now we will draw to see the difference. We will draw graphs to know how it looks like. We will take the example. For this case, we will take the example 3x, 3 power x. A greater than 1. Since 3 is greater than 1. In this case, we can take 1 by 2 whole power x. Since 1 by 2 less than 1, greater than 0. Clear?
Yes,
Yes,
sir.
sir.
Now coming to the 3 power x. Now let's take x values, x and y. We'll take -2, -1, 0, 1, 2. 3 power -2. What is the value of 3 power -2? 3 power -1. 3 power 0. 3, 3 square. You can use calculators. No. Okay. How will you do 3 power -2? Don't use calculators.
1 by
3
9.
power -2. Yeah. It is in the form of a power -7. What is value of a power -7? 1 by a power n.
1 by a power.
So 1 by 3 square. That equal to 1 by 9. Which is, what is the value of 1 by 9?
0.1.
0.11.
0.111.
So is equal to 0.11. This is equal to 0.33. Since 1 by 3. 3 power 0. What is the value of 3 power 0?
1.
1, sir.
1, 3, 9. Now let us draw a graph. A rough graph. 0 till 9. 1, 3, 4, 5, 6, 7, 8. 6, -1, -2. Look. 6, 7, 8, 9. Look, listen this carefully. -2. 0.1 somewhere here. -2, 0.11. Somewhere here. I'm coming to the -1, 0.33. Somewhere increasing greater than this. And 0 is 1. And 1 is like 3. 2 is 9. Look, the graph goes like this. Agree?
Yes, sir.
Yes, sir.
Yes, sir.
Clear? It is like increasing. Increasing,
Yes,
agree?
sir.
Now coming to the, now do like, let's take, do for this, -1 by 2 whole power x. Do for -1 by 2 whole power x. So not -1 by 2, 1 by 2 whole power x. Sorry. What guys are you doing?
Yes, sir.
Look, I'm doing this problem. Zero, 1. Are you able to understand this calculation?
Yes, sir.
Yes, sir.
Yes, sir.
Now we'll draw the graph. 1, 2. Now I'll check for -2. For -2, it is like 4. -2, 4. -1, it is 2. 0, it is like 1. And 1, it is like 1 by 2, 1.4. And it is like for 2, it is like 1 by 4. Look at this graph. What is this graph?
Decreasing.
Or decreasing.
Decreasing. Decreasing function. So here we can write this as decreasing and it as increasing. Clear?
Yes, sir.
Yeah. And then moving to the next topic, natural log, natural exponent. Which is like e power x. E power x. So actually e is greater than 1. Remember this. E is greater than 1. You can find e. Actually e is 2.7, something like this. But you will learn in logarithms, don't worry. But here in this week, you can consider, I mean, it is enough to know that e is greater than 1. Because if someone gives you graph, like if someone asks you how the natural exponent graph looks like, how does it look like?
The increasing.
Increasing function. It looks like a power x when a greater than 0. Agree?
Yes, sir.
Yes, sir.
A greater than 1, not 0. Hello.
Yes, sir.
sir.
Clear till now?
Yes, sir. Clear.
Now we will learn about some properties. Please remember this. Actually, you will find explanation in upcoming weeks of week 1 for this, but in this week you have to remember this. Okay? Properties of natural logarithm, natural exponent. Listen this carefully. If you draw natural exponent, how will it look like? Similar to this.
Yes, sir.
So I'm only drawing this side half. Okay. Now look, if someone asks, look, area under curve f of x is equal to e power x from minus infinity to 1 is e. Hello.
Yes,
Sir.
sir.
Yes.
Clear? Look, if someone asks from minus infinity to area somewhere, 1 is somewhere here, then this area value is e when this curve is e power x. Clear?
Yes, sir.
Yes, sir.
What is the e bar x, sir?
Hello.
What is the e bar x, sir?
Function. This is a function.
Okay.
And then coming to the next one. Okay, if you draw tangent like
Sir, can we calculate unbounded area?
hmm?
We can calculate also unbounded area.
Actually, you can do that. I mean, like not unbounded. You will take it as like bounded from minus infinity to 1. Like you can calculate. If the I mean like you will get to know in next chapters of in integrals. You will get to know. Don't worry. Hello.
Okay, sir. Thank you.
In integrals, that's it. I said you that for understanding to derive this, you have I mean like you have to complete the whole max 1 course. Right? You will get in like week 8 or something in integrals. You will get this in integrals.
Sir, please repeat, sir, area of E, sir.
Look, area is E. Like this is f of x curve. This is f of x curve. Agree?
Yes, sir.
If you take from 1, like from x-axis 1 to minus infinity, the area bounded is like E. Value of area is E.
Okay, sir.
Clear?
Yes.
Clear for everyone?
Yes, sir.
Yes, sir.
The next point is like E is slope of tangent f of x is equal to e power x at 1 comma e. This point is listen this carefully. This point is 1 comma e. Agree?
Yes, sir.
Why it is 1 comma e? E power x, e power 1 is e. That's why it is 1 comma e. Agree?
Yeah.
So
Yes, sir.
Yes.
if you draw a tangent, the slope of tangent is equal to e. Clear till now?
Yes, sir.
Yes, sir.
Yes, sir.
Then we'll do one example problem. Okay, before doing example problem, let us do this. I want range. We have seen the function a power x and a greater than 1. I need domain, range. I need domain range, and for similar to a power x, when a is between 0 and 1, domain and range.
Sir, domain is
For e
open
power x
bracket
also.
1 to infinite.
E power x also, domain and range.
Sir, in a cube power x, domain is open bracket a to infinity.
Think carefully. Like,
Sir, it's R domain.
Yes, some more answers.
What, sir?
Just type in chart box. Like I'm seeing the chart box. What is the range and domain of all these three functions?
1 to infinity, sir.
Hmm?
The domain is all real number.
Domain is okay. Because x can take any value.
And the range is 0 to infinity.
Range zero to infinity, open bracket or closed bracket. Is 0 included or not? That's the point.
So
Not
0 is not
included, sir.
included, sir.
No, sir.
And
Not
open
included,
bracket.
sir.
zero.
Not included, sir. Open bracket.
0 to infinity. Okay, clear?
Yes,
Yes,
sir.
sir.
Now some more
So how
things.
is the range 0, infinity, sir?
Look, a power. What is the value of a power 0?
1.
Whatever you do, I mean, like whatever you select this x value, you can't get 0. Function value can't get 0. You can see this in graph. Look, does graph touches anywhere at x-axis? Look, any exponential graph won't touch x-axis. Hello.
Okay, sir.
Now I am asking x-intercept.
Zero, sir. No, no x. X is
No.
not accepted.
No x-intercept.
Yeah,
No.
no, because graph curve will not intersect. Huh?
Y-intercept.
So 1.
So 1.
1. Okay. Compute all this to when 0 and 1. In between a is in between 0 and 1.
So domain R.
The domain R, range open bracket 0 to 1.
0 to 1.
0
Open
to
0 to open 1.
Infinity.
1.
why 1, man? Look.
Infinity.
Infinity.
Look, it goes till infinity. Why 1? Are you getting the point? See the graph. It goes till infinity. Till infinity. Yes. Clear? Hello.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Till infinity.
Sorry.
What is the x-intercept?
No
X.
x-intercept. And y is 1.
Oh, no.
No x-intercept. Y is 1.
Y-intercept is 1.
Is
What about e power x?
All the same data for the e power x.
all.
Which data? Which one?
Real number.
This or
First
this
one,
one?
sir.
This.
If
Sir,
e is
take the
greater
power
than 1, then all the same data of e to the
Yeah.
power x.
Yeah, where a is
So-
greater than 1.
So e power x and a power x. I'm writing there itself. Okay. I'm not writing separate. Now we will consider other things also.
Okay.
Now I'm asking and behavior. Of both things. We already calculated for polynomials and behavior. X tends to infinity, x tends to minus infinity. The same way, x tends to infinity, x tends to minus infinity.
So for x tends to plus positive infinity, y is also tends to positive infinity plus infinity.
Yes, sir.
In which case?
Or X
In which
tends to
case?
minus
First case, in
infinity.
the
The
first
first
case.
case, sir.
And
The
in
first
First
case.
case,
yeah,
x tends to
Or
infinity, what will happen?
X minus
y
infinity
is
sir,
also
it
is
tends
plus
to 0 to
infinity.
Y tends to infinity.
Yeah, y tends to infinity.
Behavior is infinity as y is going to be infinity.
X
What
tends to
does
0, sir.
Y tends to 0.
Tends to
0?
0.
Remember this
The 0.
carefully.
Zero.
This is
It tends to zero, right?
what
It
happens
is
in this case?
decreasing.
So it also goes to x.
X
Y
tends
tends
to
to
infinity. Y tends to infinity also.
0.
infinity.
No, sir, it tends to
0.
0, sir.
Why zero? Someone says zero and infinity. There is conflict. Why zero? Why infinity? Explain me.
Sir, because graph tending to minus infinity is y equal to infinity and x equal to infinity, then y equal to 0, sir, tending 0.
Yeah, good. You observed graph, but
But
someone actually
in second case,
explain me.
graph is decreasing.
Yeah, okay. Graph is decreasing. Good explanation, but I need in terms of mathematics. Like
As we see from the graph that x is increasing, that y is also increasing, and
no, I
if
don't
we
need graph. Look.
Sir,
I explained
actually,
you graph.
second case,
Sir,
a value is lying between 0 to a. So if we increase the x, then the denominator of the a will also increase. So the value is
Yeah,
tending to
you got
0.
some close. I will explain
decreasing.
you.
Um,
You got some close. Look.
1 by
Yeah, 1 by, that's the reason. A power minus n. That's the exact answer. Look, in between 0 and 1, if something is in between 0 and 1, it is fraction.
right,
Agree?
Yes,
Yes,
right,
sir.
sir.
Fraction can be written as, for suppose 1 by 2,
right,
whole power something n.
Um,
and
Indirectly,
right,
it is 1 by 2 power n, that equal to
yes,
2 power minus n. Agree?
yes,
yes, sir.
If
and
you put infinity, plus infinity, you are putting 1 by minus infinity instead. Are you
yes,
getting the point? So it is 0.
zero,
Yes,
right,
Okay.
Yes, sir.
okay,
Y tends to
right,
here
sir.
infinity. Clear?
sir, infinity.
Yes,
Yes,
Are you getting the point? You got, I mean, like,
yes,
you understood in a pretty good way using graph, but I want to make sure to understand the mathematics also. Clear?
Okay, sir, okay.
yes, sir.
Clear till now?
Got it, sir.
Yes, sir.
Yes, sir, clear.
Now we will solve one example. Look, like, let R of T be the percentage of people who respond to affiliate links in YouTube. R of T. R of T be R of T equal to 50 minus 100 e power minus 0.2. This R of T represents number of, percentage of people. Percent of people respond to affiliate links. Now someone is asking that. Now the question is, what percent of people respond after 10 minutes? Did you get the question?
sir.
Yes, sir.
uh,
To solve this.
Excuse me, sir. In
Yeah.
questions like these, do we have to take the values in standard measurements like seconds, meters, etc.?
Yeah, they will give. Yeah. 10 minutes. And they will give in this T in minutes. Look. Oh, sorry, I didn't give here. they will give t in minutes. If they give t in seconds, for suppose I am putting it in red mark, please take note of it. If they say t in seconds, if the question is in minutes, you have to convert minutes into seconds. Clear? Hello?
Yes, sir.
Are you getting the point?
Yes, sir.
Okay, sir.
Don't worry, here the t is in minutes.
Sir,
50 minus 100 by e square.
Huh? Hello?
50 minus 100 upon e
E
square.
square.
E square. 100 into e square.
Upon, divided by.
Divided
Divided by
by.
e square.
Okay, okay.
सर बट आंसर ऐसे तो नहीं मिलेगा, उसको आगे सॉल्व करना पड़ेगा ना.
Do we have to put the
We know
value?
the value of e, right?
Yeah, 2.7. Do we need to put the value?
Yeah, you can put if you want.
But in this week, sir, we not know, sir, equa.
Yeah, you don't know e value. Don't worry. Okay. And then coming to what is the highest, second question. I am solving this. R of t is equal to 50 minus 100 e power minus 0.2 t. 50 minus 100 into e power 0 minus 0.2 into 10. 50 minus 100 power minus 2. It is approximately, it comes around approximately 36.46. Okay.
Okay.
Yes, sir.
And then coming to the question B. What is the
Sir, how is answer the 36.46?
like? I mean, like, you will know the e value in next. I mean, like next thing 2.71 for something like this, and you have to square it and you have to divide it. Clear?
Okay.
What is the highest percentage? Highest percent expected. Why are you taking this much time? It is very easy.
$50, sir.
The 50?
Why 50?
The 100 e power minus the whole factor, it tends to 0, then the remainder will be 50.
Yes, sir.
R of t is equal to 50 minus 100 e power minus 0.2 is. Yes, there is a symbol minus here. The highest possible is if it is 0. If it is 0. So, when it will become 0? As it is e power minus, if it is
20.
infinity. So, at t equal to infinity, remember this, at t equal to infinity, 100 e power minus 0.2 t tends to 0. Agree?
Yes, sir.
So,
Yes, sir.
R of t tends to infinity is equal to 50. Clear? Hello?
Yes, sir. Clear.
Yes.
Yes, sir, clear.
Then I will brief you one thing. For suppose there is There's a function like this. It is like q equal to q naught into e power minus bt. Hello.
Yes, sir.
Now, if someone where q is production rate
Production rate. Okay.
and q naught is initial production rate.
Okay, sir.
This graph is between q and t.
T. T
If
is the
someone
time.
t time, yeah, t is time. Where t is time. Look, if someone asks you total production, not the flow rate, how will you calculate? From time
Will
t equal to 3 days to t equal to 10 days. Are you getting the point?
yes, sir.
Yes.
So we'll have to take the area from
Yeah,
3 to 10.
we have to take the area.
Area under this curve.
Yeah, why area?
Rate.
Q is look, rate into time is like production.
Yes, rate into time. Right.
Rate for suppose rate is in like liter per minute, liter per day. But we won't measure in liter per day, that is another thing. But time is in days.
In days, yes.
If you multiply liter per day
Yes.
into days,
Liter, that is the
is
total
equal to
production.
liter.
Right, sir. But the
Clear?
unit is clear, sir.
Yeah. Just I want to say that you can find the total production rate also. That's why that's why I said you this. Okay. Clear till now?
Yes, sir.
Yes, sir.
Now we are moving to the final topic, important topic, very important topic. Composite functions. So, just wait for 1 minute. Composition of function.
Composition. F of x, f of g of x.
Look, f of g of x is equal to
Yes.
f of g of
F
x.
of g of x. It is written as. Right, sir.
Now I will ask you one question, like define range and domain. Define domain. Define domain.
Domain is that what g of x.
G of x.
Look, listen this carefully.
Domain is the range of g of x, sir.
X is domain of G. Agree?
Right. And g of x is the domain of f.
The range of g of x is domain of
G of x
is the domain of f.
Domain of f. Clear?
Right. Okay.
Clear till now?
Right, sir.
Now there are two important points. Listen this carefully. If x does not belong to domain of G, then implies x doesn't belong to domain of FOG. Agree?
Agree.
Yes, sir.
Yes, sir.
The next thing is like x such that g of x does not belong to domain of F must not be included in domain of FOG. Look, if g of x is not in domain of F, then it will not be in FOG, domain of FOG. Clear?
Okay, sir. Right, sir. Clear.
Now, what is the use of this composition of function? Can anyone tell me? Why you need to, I mean, like,
It is used to manipulate the many functions in combining the one function. Like, I
okay,
don't know
combining
here.
function. Okay.
Yes.
How will you find inverse?
That like example, if e raised to the power x and log of x we combine each other, then f of g of x, like g of x is e raised to the power x and f of x is log of x, then we manipulate it like the combining it, like f
Oh,
composition f of g.
don't worry. I will explain.
Okay.
For suppose we will do some example now. Make you understand. Let f of x be 3x square plus 8 and g of x is equal to 10x plus 4.
Okay.
FOG of x.
Right, sir.
Find FOG of x.
1 minute, sir.
And G of f also. G of f of x.
Do we want to find out, sir?
Yeah, you have to.
Sir,
Sir, f of
FOG's
g is
values.
300x
Square
square plus
plus 80x
240x
plus
plus
32.
56.
Yes, sir.
And sir, GOF is 36x square plus 84.
FOG of x is 30x square plus 240x plus 66.
Both are equal.
Both are equal.
Equal.
Yes, sir.
Sir, I doubt this part. Both are not coming equal for me.
They won't be equal, sir.
Why? Why? You're just reversing the function. Why it is not equal? Just check again.
Yes, sir. G of f of x is 30x square plus 84. It is not the same as f of g of x.
Yeah.
Yes, sir.
Just wait. I'm stopped sharing the screen. Just wait. Okay.
Both are not same because the composition is different.
Yeah, it is different. When it will be same, f of g and g of f. I mean g of f of x will be same. When both will be same. Can anyone
Then
tell
When
that?
f of x equals to gx.
Both functions equal?
when the both functions are maybe
So,
x is
so when
same.
range of FOG is equal to domain of GOF.
Have you just take? I mean, like, did you watch week 5 lectures?
I think one fx is mirror image of gx.
No, answer my question. Like, did you watch week 5
No,
lectures?
sir, not
Any
so
one of
early.
you, at least one.
Sir, but I think if they are inverse of each other.
Yeah, are you getting it? When it is inverse, then both will match. I will explain. Don't worry. Just don't worry. Actually I want to include one problem in the That's why I'm downloading that problem.
Can I ask a question, sir?
Yeah, you can ask.
As our first use on the J-based entry, 16th July, right, sir?
Actually, I don't know exactly about that. Sorry.
Uh, it is based on the 4 weeks or 5 weeks included, sir, in the quiz one.
Only 4 weeks.
Only 4 weeks, na, sir. Yes, sir, because 5 weeks are also with there on the dashboard, so we just confused.
4 weeks.
Only 4 weeks. The basis on the 4 weeks, the quiz one is held on the 16th July.
Are you able to see my screen now?
Yes, sir.
Right, sir.
Yes,
Yeah.
Yes, sir.
How many hours the qualifier exam will be conducted, sir?
I don't know about that also.
4 hours
Hmm?
if you have taken 4 subjects.
Look.
1 hour
FOX.
for each subject.
So let me finish this. Okay. You can discuss in your WhatsApp group. 3x square plus 8. This can be written as f of g of x.
X, right.
F of 10x plus 4. What equal to? Look, wherever there is x, replace with this. 3 into 10x plus 4 whole square plus 8. 3 into 100x square plus 16 plus 80x plus 8.
Plus 8, right, sir.
300x square plus 48 plus 8 plus 80x. 300x square plus 80x plus 56. Clear?
Right, sir.
F of g of x. Coming to this GOF of
Sir, you
x.
haven't multiplied 80 with 3.
Yes, sir.
240. Yes, sir. This will be 240.
There's a 240x.
40. Now coming to g of f of x. G of what is f of x? 3x square plus 8. 10 into 3x square plus 8 plus 4 or minus 4?
Plus 4, sir,
Plus
also. After the bracket.
30x square plus 80 plus 4.
So that is
30x
30
square plus 84. Both are
Right,
not
sir.
equal. F of e is not equal to g of
G of
x.
x.
Okay. Now we'll solve one problem with some.
Shop is offering to discounts on product with an MRP of 1400. So the
Are you able to see the problem?
right, sir.
Yes, sir.
The first discount is 15% discount on the MRP, and the second discount is a flat 3000 discount. For discount are applied. What is the final cost?
Excuse me, sir. What is the order in these? What do you call it? Order in these discounts. Is the 15% and before, then 300 minus,
No,
or is
just
it
solve.
300 minus or
Just
15%?
solve. Just solve first. Then I will explain what we have done the mistake. Okay.
Okay.
Okay, sir.
They
8900,
clearly gave.
sir.
Look. They clearly gave what is the first discount and what is the second discount. Read that.
8900.
Okay, let everyone do that. Just put.
Sir, 8900.
Now I am solving this. Look, first discount is 15%. First discount is equal to 15%. That is equal to 0.15. Let original price be X. So after first discount, price of article, price of item is equal to 1 minus 0.15 into X. That is equal to 0.85X. Agree? Hello. Hello.
Yes, sir.
Yes, sir.
Then coming to the second discount. Look now. Listen this very carefully. I'm
Sir, the
doing
MRP
this.
is not the original price, sir.
Huh?
The
MRP is the
MRP
original. MRP is the original price. Yeah. Let MRP be. Okay. MRP.
we can write X as MRP. It's 14,000.
MRP BX. Now look. After second discount. Listen this very carefully. Like 0.85X minus 3000. Agree?
Yes, sir.
Yes, sir.
Clear?
Okay, sir.
We don't know the problem after second discount.
What, sir?
What should we need to find? Like after second discount?
The
Cost price,
final
sir.
cost.
Yeah, after second discount. The final cost is after second discount. Agree?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. They given the MRP
we,
of the item as how much
we
is the
put
MRP?
X, yes, sir. X to put करेंगे now as
14,000
14,000.
minus 3,000.
Right, sir. Then it gives us
8,900.
8,900.
Okay. Now I am doing the same problem in other way. Listen this carefully. Let same first after first discount equal 0.85x.
Okay.
After second discount x minus 3,000. Okay, only second discount. We will put only second discount. Only second discount x minus.
Yes.
Look now what they said. Understand this clearly. What they said, applying both discount. One and two. Okay.
Okay, sir.
Let this be g of x. Let this be f of x. Yes, this is first function. I mean, first discount is f of x and second discount is g of x. And the combined discount is h of x. Now my question is, h of x is equal to f of g of x or h of x is equal to g of f of x. Which one is correct?
Okay, sir.
F or G of X.
Give me some time, sir.
Or G
So you are
of
checking. You are checking.
G of F, sir.
Look.
Sir, GOFX.
Why? I think many people are checking the answer. This is correct. Why? Look, listen this carefully. H of x is equal to g of f of x. Look, this is first discount. You have to put the first discount in the second discount thing. Are you getting the point? Inside out. Hello?
Yes, sir.
Yes, sir.
Clear?
Yes, sir.
Yes.
You will get the same answer. Follow this. I am solving this. G of what is the f of x value? 0.885x.
0.85.
0.85x minus 3000. What is the x value? 0.85. H of how much? 14,000. 14,000 minus
Yes.
3,000.
You get the
H
same.
of 14,000 is equal to 8,900.
8,900.
Clear? Order is important. Hello.
Yes, sir.
Yes,
Clear.
sir.
I'm coming to the we'll solve this question also. Example 2. Domain of f of g of x. And f of x is equal to 2 by x minus 8 and g of x is equal to 38 by x square. What is the domain?
R minus 08.
Yeah. Look, when this function fails, when x is equal to 8, this function fails. When this fails, when x is equal to 0. So we have to remove all this. I mean, like domain of f of g is r minus 0 comma 3. Agree? Clear? Hello.
8.
Oh, sorry. Yeah.
0, 8. Okay, sir. Okay, sir. Now I understand.
Now the final topic of the fun.
Excuse me, sir.
Sorry, sir.
Yeah.
So in the last part, shouldn't that domain like R should be x should not be equal to 0 and g of x should not be equals to 8?
No. You are asking the domain of complete f of g.
Yes, sir. Then we will not put the value of x equal to 0 because it will not satisfy g of x. Then, sir, we have to put the value of g of x such that it is not equals to 8. Shouldn't that how it work like?
No, not. If you're combining these, I mean, like both f of g of x, then you have to take both. Like if one function doesn't exist, the other function should also doesn't exist. Are you getting the point? As we are finding the domain of f of g of x. That's the reason.
Yes, so
Look.
after writing the f of g of x, the function is like 2x square upon 38 minus 8x square, sir. In this, we got confused, sir. How to write the domain.
Okay. You want to write the domain? Okay. Oh, you want to check whether this is correct or not?
Yes, sir.
Okay.
Sir, one question, sir.
F of g of x. Yeah.
Apart from a 0 and 8, don't we have to substitute in f of x the function of g of x and see where that denominator should not be equal to 0?
Look. I'm doing that. Don't worry. Just wait. You'll understand after I'm finished this. 2 by 38 divided by x square minus 8. Agree?
Right, sir.
2 by 38 minus 8x square, x square. Okay?
Right. Okay.
X square divided by, what is this? 19 minus
Yes, the base is not equal to 0.
4x square. Okay?
Yes, sir.
Clear?
Yes, sir.
What happens? 1 by 19 by x square minus 4. Agree?
Yes, sir.
1 by 19 by x square minus 4. Now look, this must not be equal to 0. 19
Right, sir.
by x square minus 4 not equal to 0. 19 by x square is equal to 4. 19 is equal to 4x square. X square is equal to 19 divided by
4.
4. X is equal to plus or minus root of 19 divided by 2.
2. Right, sir. There is a confusion.
Just wait.
It only shows that x is not equal to plus root 19 by 2 or minus root 19 by 2. Not gives us the range, like 0 to 8 or whatever. Hello, sir. Hello, sir.
Hello. Just wait. I'm
Okay,
checking
sir.
whether the okay, there is a mistake. Sorry, there is a mistake. You have to do like this. Sorry for this. I have done some mistake. You have to check like this. F of g of x.
Okay.
Then it would comes around 1 by 19 divided by x square minus 4. And finally, x doesn't equal, I mean, like, what is the domain?
Yes.
R minus plus
R minus plus minus root 19
plus or
upon
minus root 1.
R minus root 19 divided by 2, comma, minus root 19 divided by 2. Okay, clear?
Yes, sir.
There is a small mistake. Sorry for that.
Yeah.
So 0 as well.
No, why
You
0?
don't need Zoro.
Minus
No,
19
no.
by 2, 19, root 19 by 2, sir. Negative to positive, no?
No. You can take 0. Only these two will not be there. Okay.
Okay.
Then coming to the final part of this. inverse functions. When does inverse exist?
So when the function is differentiable,
When the function is 1-to-1 and on-to.
When the function is bijective, sir.
Bijective?
Yes, sir. When the bijection of the function is possible, then we take the inverse of the function. Am I right, sir?
If the function is 1-1, you can do inverse. Like,
but both conditions should be met. That 1-1 on 2.
coming to the inverse functions, like just if
The inverse
f
of
is
bijection
1-1, if f is 1-1,
or
then
on 2.
f inverse exists. Now remember, listen this very carefully. F inverse of f of x is equal to f inverse of f of x.
Right.
Now listen this very carefully. If x belongs to domain of f, x belongs to domain of f, that equal to the range of f minus.
F minus.
Clear?
Right.
Similarly, f inverse pod of x, f into f inverse of x. Now, how will it will look like?
x.
So x.
X belongs to what?
Range of x.
Range of f that equal to domain of f inverse. Or you can do it simply like domain of f inverse that equal to range of f. You have to take like this. Agree?
Yes,
Hello.
sir.
Here. Now the good thing about this is like, listen this carefully. Graph of f inverse is symmetric about y equal to x. Why?
Yes, sir.
Look, now I will tell you. If someone asks you 3x minus 5 by x minus 3, inverse of this function, f of x. You want to find inverse of this. How will you find it?
Sir, we switch x and y. Like where is x, we put y. Where is y,
Huh?
we put x.
Okay, do like that. Just tell me the answer.
Can equate it to y and
Yeah.
take x from
Correct procedure is like put y equal to 3x minus 5 x minus 3. Y into x minus 3 is equal to 3x minus 5. Xy minus 3y is equal to 3x minus 5. Then xy minus 3x is equal to
3x
3y
minus 5
minus
upon
5.
3x minus 3.
Now x take x comma. Y minus 3 is equal to 3y minus 5. X is equal to 3y minus 5. Y minus 3. This is inverse.
Yes, sir.
Okay. Now, okay. How can you check whether this inverse is correct or not? Check
Substitute
whether
f of x.
f of x, f inverse of x is equal to 3x minus 5, x minus 3. How will you check?
You substitute the y of x equals 3x minus 5 by x minus 3 and see if it equals x in the end.
We are doing the same procedure reverse. Look.
We'll find the domain.
Use this. If, listen this carefully, if f of g of x is equal to g of f of x, then f of x, then g of x is inverse of f of x. Very, very important. Did you get this? Hello?
Yes, sir.
Now apply this and find whether this f inverse is correct or not.
You want to find us?
Yeah, you have to find.
What's up?
The place are once past the previous sum, sir.
Look this. 3x minus 5.
Yes, sir.
Yes, sir. F of gx is equal to g of x.
Is equal to x. Look. 3 must look. F of g is equal of x equal to g of x is equal to x. This is the condition. Are you getting equal to x? Hello?
Sir.
Are you getting the value equal to x?
F of g of x means what to do? G of f of x means what to do, sir? You want to substitute the value of x only, no, sir?
Okay. This is inverse function. Look. F of x is equal to, I'm doing this, 3x minus 5 divided by x minus 3. Coming to other thing, f inverse of x, let it be g of x, is equal to 3x minus 5 divided by x minus 3.
3 y, sir.
No, here we put x now. Hello. F inverse of x, that's why we're replacing y with x. Hello.
Yes, sir.
So, f of g of x is equal to f of 3x minus 5 by x minus 3. That equal to you got same. Three into 3x minus 5 by x minus 3 minus 5 divided by 3x minus 5 into x minus 3 minus 3. 9x minus 15 minus 5x minus plus 15 divided by 3x minus 5 minus 3x plus 9. That equal to 4x divided by 4. That equal to x. Agree? Hello. Hello.
Yes, sir.
Yes, sir.
If you find g of x also, g of f of x, you will get the same. So, yes, f of g of x is equal to g of f of x is equal to x. So we can say f of x, g of x is inverse of f of x. Clear? Now find like inverse of, find inverse of x minus 5 on 2x plus 3. Hello? Are you guys?
Yes.
Find the
3y,
inverse of
3y plus 5
3y
minus
plus 5
1y.
upon 1 minus 2y.
Okay, I'm solving this. What it equal to y? Y equal to x minus 5 into 2x plus 3.
Plus 5 upon 1 minus 2y.
2xy plus 3y equal to x minus 5.
Right.
3y plus 5 is equal to 2xy
Minus 9.
2xy minus x. 3y plus 5 divided by 2y minus 1 equal to x.
One thing is wrong, sir.
Yes, sir.
X minus 2xy, sir. Here. The second step.
Stop. 2xy plus x minus 5. 3y plus x minus 2. Okay.
5 is there, then this is
X
x
minus
minus
2xy. Then it will
Then
become 1 minus y.
1 minus 2y.
Okay.
Yes, sir.
So if someone asks f inverse of x is equal to 3x plus 5, 1 minus 2x.
Yes, this is the inverse of that function. Okay, sir.
Okay, clear?
Okay, sir, clear.
Any other doubts?
Sir, can you move the slide? Thank you, sir.
Sir, excuse me, sir.
Yeah.
Sir, how f inverse x becomes 3x plus 5 divided by 1 minus from 2y to 2x?
Look. Here, this is just f inverse. Here we put f inverse of x. We can replace
Yeah.
y by x.
Then y, all y becomes x.
X, yeah. That's it.
Okay.
Okay, clear? Any other
Clear.
doubts?
No, sir. No, sir. This is session only for the week 5 students, sir. Or can we ask about the week 4 or week 3 doubts?
You can ask, like, there is still some time left now. You can ask.
Yes, sir. So there is doubt in the week 4, practice assignment not graded, and the question number is 8.
Just wait.
8, 9.
Week 4,
Yes,
practice
sir.
assignment.
Practice assignment, question number 8, 9.
Just wait, it is loading. Just I'm opening the question.
Excuse me, sir.
Yeah.
Sir, all exponential function is one-to-one function, right?
Yeah.
If we move almost x tends to infinite, and then we draw a horizontal line, then it will be superimpose almost x tends to infinite, or it will be superimposed or not
I'm not
on
getting
the
your
curve.
point.
Right.
Hello?
Sir, actually, exponential function is one-to-one. Okay.
Yeah.
If we move on the x-axis in positive or negative direction, almost x tends to infinite, and we draw a horizontal line, then this horizontal line will be superimposed on the curve almost when we are on x tending to infinite. Then it will be superimposed on the curve or not.
Okay, whole curve. You are checking only one point. What about the whole point? You are asking that.
Sir, actually, we are checking when x is tending to infinite.
Okay, okay, x is tending to infinite.
Yeah. Then horizontal line superimpose on the curve. Then
Okay,
it will be many to one.
You're drawing horizontal
I
line.
think.
After that?
Yeah. If we draw horizontal line, almost x tending to infinite, then I think it will be superimposed on the curve.
No. It won't. Look. It is constantly decreasing, and look. That's why. Take any constantly decreasing. Take any decreasing curve, and you draw horizontal line. You won't get. I mean, it is decreasing, man. Look, it is decreasing, not increasing. Look, two equal. I mean, you have learned about turning points in polynomials. Why you have learned about turning points? Look, if your graph is continuously decreasing, then there is no chance to be equal at 2 points. Look, without turning point, how can be two values equal? Without turning point, just tell me. If graph is going like this, how can two points be equal without turning point?
No, there is no 2 point equal without turning.
Yeah, that's why. That's the reason why. Look, it is constantly. It is decreasing. It is decreasing continuously. Now, if you draw till infinity, there is no chance because there is no turning point.
Yes.
Yeah. Okay. Yeah. Okay, sir.
This is
Thank you.
exponential function. So can you solve my doubt, sir?
Just wait.
Okay, sir.
Still loading.
Sir. Hello, sir.
Hello, yeah.
In the evening, you also come, sir, in the session. There is 6 to 8 p.m. session.
No, TS session it is.
Yes. Who will take that session, sir?
No, TS will take. I don't know who exactly. TS will take. You're asking about week 4.
Yes, sir. Practice assignment question number 8.
Totally, how many types of sessions, live sessions are there?
Per week. Like there are TS sessions and like instructor open sessions.
TS session.
And where do we find the calendar, sir?
Just go to like you're not getting access to calendar. Just go to
Sir.
Gmail, mail, and then there will be calendar, Google Calendar. Look.
Okay, sir.
No, sir. Live session update is on the inbox in our dashboard, sir.
Every time, not in Google Calendar. No, check. There will be Google Calendar also.
No,
Sure.
sir, in dashboard, add sir Google Calendar, so we can access the Google Calendar.
Oh, can you tell me the question? Like, hello.
Yes, sir.
There's a problem with this. Can you tell me the question?
The question is, can I tell?
Yeah.
By dividing a polynomial p of x with another polynomial q of x, we get h of x as the quotient and r of x, which is not equal to 0, as the remainder.
Yeah.
The question is, the maximum degree of r of x can be. 8th question.
Okay. Answer. Like answer is 0. Like maximum degree. They ask maximum or minimum.
The maximum, sir.
What is the maximum degree?
Yes, sir. The maximum degree of r of x can be.
Hmm.
So the option is degree of p of x, degree of p of x
Look, stop. I will explain you this. You will answer that. Don't worry. Look. Polynomials. What are the things? R of x divided by R of x. You will get remainder R of x.
P of x is divided by Q of x.
P of
Yes,
x divided by Q of x.
Yes.
Here P of x and here Q of x.
H of x is quotient.
H of x is quotient.
Right, sir.
Look, listen this very carefully. When we will get remainder?
Yes, sir.
When you will get?
What, sir?
When you will get the remainder? Look, for suppose x cube plus 3x plus 8, 3x square plus 8x plus 6 divided by x minus 4.
Okay,
X
sir.
cube. Sorry, x square. X cube minus 4x square.
Right, sir. We will live with
minus plus 7x square plus 8x plus 7x.
7x.
Sorry, yeah, 7x square minus 28x. Agree? Minus plus 36x plus 6
Yes.
plus 36.
Right, sir.
36x plus minus 36 into 4 sum. 36 into 4. 144.
Yes, 144.
150. This is the remainder.
Right,
This
sir.
is the remainder. For suppose,
Okay.
do the same with x power 4. Do the same division with x power 4. Put x power 4 here. X power 4 plus 3x square plus 8x plus 6. Plus, then it will become x cube. X power
X cube.
4 minus 4x cube
Yes, sir.
minus plus
Yes, 7x cube
4,
plus 8x.
4x cube plus 3x square.
7x cube, sir.
No, this is x square
Okay, sir. Okay, sir. 4x.
plus 4x square. 4x cube minus 16x square.
16x square.
Okay,
Okay, sir. It is 19x
minus
square.
plus 19x square plus 8x
X.
plus 19x 19x
Right.
square minus
36. Nice to know, sir.
19 into 4. 4 minus 36, 76. Huh? 76. 76x.
Right.
So now it will be minus and it will be plus
76, 8.
84.
84x
84x plus 6 plus 84.
84.
84x plus 84 into 4 something. There will be some remainder. Look,
Right, sir.
Listen carefully.
Okay.
Here, if they ask maximum remainder, minimum, it is like 0.
Maximum.
Look, minimum it is 0. You can clearly say.
Right, sir.
Now they ask the maximum. When will you stop the division? Why you stopped at 6?
Yes.
Why you stopped at 6?
Because after this we cannot divide, sir. There is no any x coefficient and we cannot proceed.
So
Yeah, okay. Hello. Yeah,
Hello?
someone is telling. Yes.
So what we cannot, because the power of the remainder is less than the power of the quotient. I mean the divisor.
Right, sir.
Yeah, that's the reason.
But then if you have a constant as the, let us say the divisor is a constant, which is a constant polynomial, then the maximum power of the remainder will be the power of, I mean maximum power of the quotient will be the power of the dividend, no sir? Instead of x minus 4, if we put just 4, whatever
Yeah.
this thing will be equal to
Then
the
the
power.
remainder will be the highest power of this, which hello.
Yes, sir. The maximum power of x will be 4 then.
Px. Right, sir.
And even
But
4 is considered as a polynomial. It's a constant polynomial.
yes, that's true.
They have not defined anything like what is a polynomial with minimum degree of so and so. Like qx is not defined as not a constant polynomial.
They didn't define anything like that.
Sir, can I leave if I don't have any doubts, sir?
Yeah, you can leave. You can leave.
Thank you, sir.
Okay, they didn't define anything like this. Just
No, sir. They just said by dividing a polynomial p of x with another polynomial q of x, we get h of x as the quotient and r of x as the remainder.
Right. Sir.
What are the options?
Options is
Degree of p of x,
degree of p of x minus 1, degree of q of x, and degree of q of x minus 1.
Fourth option is correct.
Degree. No, not about that. I want to say whether I mean like they didn't give equal to the divisor, like degree equal to degree equal to the dividend.
No, sir.
No, then you can easily you can eliminate that. I mean you can eliminate that it is a constant polynomial. Agree? Hello.
Sorry, sir, didn't understand.
If they didn't give the the remainder is like equal to the degree of the remainder is equal to the degree of dividend, then you can eliminate that. I mean, like you assumed that the divisor is of constant polynomial. Hello.
Yes, sir.
If
Just said RFX is not equal to 0. Nothing else they have put.
yeah, no, look, you assumed that this q of x is constant polynomial.
Yes.
If it is constant polynomial, what is the option, like answer? What is the answer?
Degree of
Degree
x,
of
P of x.
degree of p of x.
Right, sir.
Does degree of p of x is an option?
Yes, sir.
Yes.
Yes, sir.
Okay. Then there will be some ambiguity. Okay. They gave the answer as like q of x minus 1, degree of q of x minus 1.
No, sir. Degree of q of x minus 1.
Yeah, that's what. That is what I am telling. Q of x minus 1.
Yes, sir.
Yeah. Okay. Okay. We'll change it. There is some ambiguity. Don't worry. Okay.
Hello, sir.
Yeah.
Sir,
Hello.
can you also please
Sir,
explain
can we
the
leave the meeting, sir?
Yeah, you can do.
13th question, sir? Can you
Sir,
please
good morning.
explain?
Actually, I'm not getting the access. I don't know why.
May I share my screen, sir?
I can't give you a host access because I'm a co-host itself. Sorry.
No.
Like,
So they are saying what is the most suitable representation of h of x if h of x equals p of x into q of x minus r of x into s of x plus s of x into p of x by p of x plus p of x into q of x q square of x. I am not sure how to go about solving this, sir.
hello.
Yes, this was no doubt that the 13th question.
Hello. Hello.
Yes, sir.
Are you? Are you? Yeah. You can ask the question now.
Ask. Please say.
They are saying what is the most suitable representation of h of x given that h of x is a polynomial in x. H of x equals p of x into q of x minus r of x into s of x plus s of x into p of x by p of x whole of p of x plus p of x into q square of x. And they have given some degrees and conditions, sir. So how the question is how to go about it. They have not given the solution also. They just
Not given
given
the
some
solution.
graphs. No, they just gave graphs and they indicated which graph is correct. They have not given the solution as to why that graph is correct.
Okay, I'm sharing my mail ID. I will like just send me the question
Yes,
and
sir.
a screenshot of the question. I will write explanation. Okay.
Yes, sir. Thank you very much.
I'm putting in the chat box. Just, where is the chat? Hello.
Sir, thank you.
Yeah, I sent. No.
Yes.
You can mail. Okay.
Thank you very
There's
much,
some
sir.
problem with this. Okay. Bye. Have a nice day. Bye.
Have a nice day, sir.
Bye,
Thank you.
everyone.